Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. Today, we are going to learn object-oriented design. So let's learn sequence diagram first. The aim of object-oriented design is to design products in terms of objects extracted during OOA. Actually, in the previous phase, object-oriented analysis, we have extracted quite some objects from the business requirements, right? Okay, so based on the results of OOA, object-oriented design concludes 4 steps. Step 1, construct interactive diagrams. That is, the designer creates a sequence diagram or a collaboration diagram for each of the use case scenarios defined during the analysis phase. Step 2, construct a detailed class diagram. The preliminary class diagram created during the analysis phase is elaborated to include a full list of methods, including their signatures and return types, and data members, including their types. Additional classes and relationships are included where necessary. So this is step 2. Step 3, construct a client-object relation diagram. The designer arranges the class in a diagram that emphasizes their hierarchical relationship. This corresponds to the motion of a control flow diagram. It is also called CFD in structured analysis. Step 4, complete a detailed design. The designer then specifies the algorithm to be implemented for each method, along with the internal variables and data structures required by each method. Okay, so these are the 4 steps for OOD. One of the main activities of software design partition the functionalities identified in the requirement specification and analysis phase into specific software modules. So, what is module? In traditional structured programming, a particular function or program in a particular language is called a module. Well, in object-oriented paradigm, in object-oriented programming, an object or perhaps a method associated with a particular object is called module. Okay, so let's learn step 1 in more detail. To construct interactive diagrams for each scenario. Interactive diagrams include sequence diagrams and collaboration diagrams. Surely both the diagrams are interactive diagrams. Basically, they are trying to show the same thing. Objects and messages passed between them. But surely, things are shown in different ways in these 2 diagrams. Your students are required to learn and master sequence diagrams. So let's learn the grammar for sequence diagram. Self-coding is indicated in this way in sequence diagram. So you see, this is an object, it's an instance of class A, C1, let's say. Okay? And surely, opera is a method of class 1. Self-coding is just like this. So that means one method in the class or in the object try to call another method, or maybe itself within the same object. So it's called self-calling. So you get this curve directed back to himself. So never forget this method, opera, is a method of class C1. Got condition expression. Let's say we get object 1 initiated from class C1 and object 2 initiated from class C2. Under some condition, let's say if x is bigger than y, message 1 will be sent to object 2. Else, message 2, sure, it's a method. Method message 2 is sent to object 2. From this diagram, we should understand that message 1 and message 2 are methods of class C2. So this is the got and condition. Loop expression. Let's say still object 1 and object 2 If the loop condition is satisfied, and then message 1 is sent to object 2, let's say, for all the other lines. So that means iterate all the other lines. So that means for each other line. So it's a loop. Or maybe we can put it in this way. A variable I varied from 1 to n. So that means n times looping. And then message 2 will be sent to object 2. So this is the loop expression. Sometimes the loop expression may be expressed in this way. Let's say some events may happen, okay? Message 1 is sent from object 1 to object 2, and maybe more events happened. But all of this will within this loop condition for all other lines. M2 may happen with the condition of this loop. I varies from 1 to n. So this is another way for loop expression. So maybe totally the whole sequence diagram will look like this. Object 1 initialized from C1 sends a message to object 2. Object 2 is an instance of class C2. And surely opera 1 is a method of C2. And then C2 also sends a message back to object 1, opera 2, get 2 parameters, x, y. And surely opera 2 should be the method of C1. And under some condition, let's say condition 1, if condition 1 is satisfied, opera 3 is sent to an object of class C3. Let's take the example elevator problem. So this is just a scenario of elevator problem. We can get the sequence diagram for the scenario. Let's say an elevator user press floor button. So that means this message is sent to object floor button. And second, floor button will inform elevator controller of this requirement. So you can see that this message is to elevator controller. And third, elevator controller will send a message back to the floor button to turn itself on. And then elevator controller will also send a message to elevator to move up 1 floor. Fifth, if the requirement is fulfilled, the elevator controller will send the message to floor button to turn it off. Once the elevator has arrived at the destination, elevator controller will send a message to elevator door to open itself. And then during the period of the timer, start timer until it ends. So you see that this is a condition. Under such a condition, if elevator user press some elevator button, the elevator button will inform the elevator controller, and in turn, elevator controller send a message back to elevator button to turn itself on. So now timer taps out, and the controller will tell the doors to close itself. And then elevator controller will send a message to elevator to move up 1 floor. Okay, so this is just the example of sequence diagram for elevator problem. Okay, so just now what we have learned is sequence diagram, and collaboration diagram is another kind of interaction diagram. Basically, all the things inside sequence diagram is here for collaboration diagram. You see that the objects, elevator controller, the elevator user, floor button, elevator, and the elevator doors. All the objects here, and all the events. See, first, the user press floor button. That means the message is sent to floor button. And then step 2, the floor button will send the message to elevator controller, and the controller will send the message back to button to turn itself on. The elevator controller send a message to the button to turn itself off. The elevator controller will send a message to elevator doors to open itself or close itself. You can see that the things that the collaboration diagram emphasized is the interaction or the collaboration among the objects. rather than the sequencing. So you can see that collaboration diagram and the sequence diagram really tell the same thing in different way. So much for interaction diagram.